So, and another level of combinational circuit called multiplexer, or we call it as MUX. So today we see the design of MUX. So a MUX is nothing but a many to one operation. So this is the simple diagram of MUX. We call it as many to one operation. So M cross 1 MUX, and which has a select lines S of 0 and S of 1. So it acts as a data selector, channel selector, frequency selector based on the applications and requirements. There is no doubt in it. And practically a MUX can be realized as a LUT. LUT means lookup table. If you want to generate a new pattern or any specific pattern, you can utilize the MUX as a LUT so that will be generated with easy configurations using FPGAs. So now shall we realize the MUX concept here. I already created a file. And I declared ABCD as my input and Y as output. So we have another input called select lines. So we call it as S as input, standard underscore logic underscore vector of 1 down to 0, because it is only 2-bit as per the diagram I have shown to you. It is only 2-bit yes. And ABCD, A may be any bits, single bit or multiple bits. I declared as 3-bit, and the concept is any one of the input will be connected to the Y based on the select lines. So 0 0 means A will be connected to Y, 0 1 B will be connected to Y, 1 0 C will be connected to Y, and 1 1 D will be connected to Y. So a MUX can be acts as a switch also. So I declared my inputs already. So now I am using a new statement called process statement. Process. My inputs are yes. Begin. Case. Yes. Is. This is the syntax for multiplexer. No change in it. Y should be assigned with A when it is 0 0. In the similar way, we have to assign all the inputs. So 0 1 Y will be assigned with B, and 1 0 Y will be assigned with C, and no need of last option because there is a default statement called others. So that must be declared. So when other statement Y equal to D. Since we started the case statement, end the case statement, end case, and end the process. So we can also label the process, like when we design large circuits, we should know how to identify the process. So for easy identification, we can also name the process like MUX block. So this is a user defined name only. So you can give any names. So I end the process with the label. That's all. So this is how a simple MUX could be developed. So if you want to see the simulation of MUX, I'll just make the simulation. Compilation successful. Compile all stimulate. Work folder. Select the MUX. By practice, obviously you will get these steps very easily. So initially we have to assign any value to the inputs. So randomly I'll give ABCD values. And select line should be selectable by us. So right click force 0 0. So now run it. Keenly monitor the Y. 0 0. 0 1. 1 0. I'm just changing only the select option. Every time when you assign the input, we have to run. Finally 1 1. So now you can see how the Y get changed. So based on the select lines, Y will be assigned to either A or B or C at a time. So this is how we realize the mux. So you can see the data flow diagram, and as I said, if you give the label name, that will be reflected clearly in the data flow diagram. So that will be easier for you to identify. So keep practicing. See you in the next session.